Analytic geometry. A very scary title. Analytic geometry. But I need to warn you about this chapter. For about 3 lessons, it seems like the easiest stuff you've seen ever. And then it gets completely out of hand. You've got to know the basics very well. So even if you find this first lesson extremely easy and the homework completely boring, do it. Get these skills down pat so when things get crazy, you're ready to go. Okay? This one's called midpoint of a line segment. It's as easy as it sounds. We're finding the middle of a line segment. Develop a formula, though. Ooh, we're going to get a formula to calculate the midpoint of a line segment. You might be like, do we really need a formula? And the answer is, yeah, we're going to need the formula. It's not going to seem like it at the first, yeah? So, midpoint. What is a midpoint? The point exactly in the middle of a line segment. And most of that should be like, well, duh, midpoint, middle, of course. But maybe this needs a little more help because it says line segment, and if you haven't used that word before, you might not be exactly clear what that is. So I'll just do a little drawing here to try and help. I'm going to do 2 different lines here, okay? This one over here is the standard line we've been doing. We call that a line. And you're like, did you really drag me in here on Monday to talk about what a line is? I did, because the word line is used sort of generally out in the world, line. But in math class, a line goes forever, both ways. Now, I didn't bust you on this on your test if you didn't put little arrows on the end of it, because we really hadn't talked about it. I chose not to talk about that right now. But if we're graphing a line, there should be arrows in the end to tell everyone this goes forever. A line segment's not like that. We usually put big, heavy dots at each end to say, that's it. Line segment ends on both sides. Okay? Now, that might not seem like a big deal, but it is for us in math to know the difference between a line that goes forever and a line segment that ends on both sides. Because I can't find the midpoint of a line that goes forever. What's the middle of a line that goes forever? There's no middle. It's forever. It's infinite. But a line segment, I can find the middle because there's 2 specific endpoints. So that's why that line segment word appears here. Well, just because you're an AP class, let's add one more in here. You don't really need this for this chapter. I don't think. I don't think it comes up. There is also this, where you make a line that has one end, but then goes infinite off the other side. Does anyone know what this is called? A ray. And we'll need those along the way as well, but not really a big part of this chapter, okay? Whew. Only have 5 slides. I got carried away with that one. That's as deep as it gets today. The rest of it is pretty straightforward, I think. You tell me as I go. I'm going to switch over to green because I'm getting excited about the whole spring thing. Yeah? Although it's been spring since January, hasn't it, around here this year? Good weather. More time? Did you get the line segment in the line? This actually matters. You think it's no big deal, but I don't say it's hard. It's not difficult, but it's a big deal, the difference here. So, I don't know. What are we doing next? I'll get my controller. That button's not working too well today. Boom. There. Investigation. Oh, investigation. Investigations in math, if you don't know, investigation is like, let's just play around a little bit with something and see if we can get some information out of it, see if we can't learn something from what's happening. But we'll do this investigation together. Plot the points 2, 1. Okay, 2, 1. And 10, 7. Got it. 10, 7. Draw a line segment connecting the 2 coordinates. Now this is different than what you did on the test on Friday. If you had 2 points on a line on Friday, you would have just drawn a line all the way through that went forever, right from end to end, and you would have put arrows at the end. Hopefully you put arrows at the end. If you didn't, I didn't bust you on it on the test. I didn't take a half mark off, but maybe I can now, right? Now that I've talked about it, maybe I can start doing that. But a line segment doesn't do that. When I do a line segment, the line goes from here to there, and that's it. Done. Line segment. Determine the point that is the center line by any means. Well, okay, this is the part of the investigation you should do. Take a second, a moment, a few moments, and see if you can decide. No tricks. Feels like I'm setting you up for a trick. I'm not. Look at that carefully and decide confidently what the midpoint of that segment is. I'm going to label some points while you're at it because we need it in the next part. So when you get done deciding what you think the center is, label these 2 points because that's what we're really going to need if we're going to build a formula. Did I give you enough time? Do you have your best guess on what the middle? No tricks. It sounds like I'm setting up for a trick. Like, you know, we do that sometimes in math. Like, doesn't it look like it's this, and then it's something else? This isn't like that. What's the middle point here? What's that?
No, wait.
6, 4. Yeah.
Is that measured and then divided?
You measured and divided. Great method. That might not have been what other people did. She took a ruler out and measured how far it was, got that distance, and that was the, 4.1 was the distance, and then found out that 6.4 was the middle. Did someone use a different method? And I'm okay with any method used.
I took the values of x and y, so I did 2 plus 10 divided by 2, and then 7 plus 1 divided by 2.
She's answering number 4. She looked at 2 and 10 and said, what's halfway between 2 and 10? And how did you decide that? What did you do again?
I did 2 plus 10 and then divided by 2.
2 plus 10 divided by 2. Yeah? She took the average here. She said, to get the x, she did, hang on, let me write down what she did here because this is the whole deal. I want to hear other people's methods, by the way. She took 10 plus 2 and then divided that by 2 because that was the average of the 2 x values. Then how did you get the y value?
7 plus 1 divided by 2.
7 plus 1 divided by 2. She's found the formula. And I'll make it into a formula in a minute. But that's what the formula is all about. Did anyone use a different method? Because I can think of at least 2 more ways that this could have happened. Eyeball works here, and I did that on purpose, right? As I looked at it and I went, let's just make this work out nice. Choose some points where it works out nice. So we get the point of the lesson. We get the point. I can think of one more method. I don't know. What did you do? Oh, the slope kind of, right? Yeah, you went, over 4 up 3. This is over 4 up 3. Those must be the same 2 right triangles. And I can picture my brain just looking at that. I've done so many right triangles. I see the right triangles there, and so that would get us there. All of that just so we're all confident. The eyeballers, the slope people, the people who are already onto the formula, and the measuring people all agree we're pretty confident we can move on. 6.4 is the right answer. Determine the point by any means. Okay, we came up with a whole bunch of means to do that. What do you notice about the values of the midpoint compared to the values of the endpoints? I don't know if this is the way she would have phrased it, but this is how I'm going to phrase it. The middle x is the average of the x's. The middle y is the average of the y's. That might be my only teaching all day. That might be my only moment where I took what she said, which is I add them together and divided by 2, and just said, well, you're finding the average of those two. You're finding the middle. Any questions about that? Here's the difficult part. The only difficult part is jumping from numbers, and everybody's happy. When I look out, everybody seems to be happy. Happily bored, you are. You're like, hey, this is easy. Then I'm going to write something that goes out into the abstract a little bit. And I want to talk about that in math a little bit. Sometimes in math, when we jump from specific to abstract, that's when your brain locks up for a second. So I'm going to try and do that very slowly, to get the abstract part of it under control. So hopefully that you're just as happy and bored as you are here. Okay? Here I go. When MAB is the midpoint, ooh, capital M, not little m. Is that troublesome? Hopefully not. Big M for midpoint, little m for slope. We do this all the time in math and science moving up. We use a capital T for temperature. We'll use a little t for time. So each letter maybe represents something different. Anyways, is the midpoint of a line segment with x1, y1, and x2, y2. See, this looks like how we write points with the slope formula. Now we're going to build a formula. The coordinates of MAB are. So the midpoint, I draw my M really big, of AB equals, well, before I write it down, let's just say it in words, because I think if you want to jump to abstract, you got to say it in words first. So let's go back to her numbers and say it in words first, not with the numbers, in words. What did she do here to get the midpoint? You're too good. He's too good. Yeah? He's got the formula already. Can someone put in words what's happening here for someone who just showed up at this point in the lesson? Not this point of the lesson, at this moment of the lesson. What did she do here in words?
You found the average of the x values.
Yes? So what operations did you do with the x values? You added them together and then divided by 2. And that leads us to the abstract formula. The abstract formula says if you've got any two x values, add them together and then divide by 2. That's how you get the x value. Let me remind you. A couple of sneers there I saw on people's faces like, this is really boring. You're going to have to trust me that this chapter has only 2 ends of the pool. It has the shallow end, which is what we're doing here, and then the deep end. It doesn't have one of those diagonal things. You know what I'm talking about in the pool? Where it's like, oh, I'll just try a little deeper here. It's like shallow, and then we'll go, woo, deep end. So let's make sure we get the shallow stuff down pat. So if this is easy, great. Knock it out of the park tonight. That was easy, all done, and I'm ready for whatever he's got brewing up as the chapter goes on. Does anyone want to take a shot at the formula for the y? Not that complicated. It's not that complicated. Now, since you have experience with the slope formula, maybe you're less than surprised by this. Let me give something away. Let me step ahead 2 lessons. There's a couple of more complicated formulas coming, and this is a good one to warm up on. Yeah? More time there? On slide 3 of 5 for me. Determine the coordinates of the midpoint of each line segment. Okay, I'm going to do the first one with you. Then you'll try the second one. You know, we like to do one where you try it yourself. And then apparently there's one extra example after that. So here's how you do it. Label these. x1, y1. x2, y2. You're like, I don't need to label them, Mr. Todd. Thank you very much, but I got it under control. Well, if you do, make that decision over the next couple of days, because I got some more complicated formulas coming for you. So for now, trust me, go back to labeling them so you got this under control. Then you write down your formula. Midpoint of AB equals x1 plus x2 over 2, y1 plus y2 over 2. Then it's just plug it in. If you know how to label the points, and if you know the formula, it's just plug it in. I'm going to say that exact line in the tougher formula days. If you know how to label the points, and if you know the formula, it's just plug it in. So I get 5 plus 8 over 2, and I get 3 plus negative 7 over 2. Be careful with the negatives, friends. As always, negatives can turn something pretty easy into a little mistake. So I get 13 over 2 and negative 4 over 2. That's what I get when I do those in my head. Now, we got to talk about fractions. If all fractions were just denominator 2, we just make them all into decimals. That's my honest appraisal of the situation. Fractions are only meant when it's like thirds, because thirds is bad, right? Crazy decimals. Fourths, we could just go to decimal every time. Fifths, decimals. Sixths, sevenths, ninths, 11ths, 13ths. These are the fractions that cause us difficulties. So for now, I encourage you to stay with the fraction whenever you can. Now, if you want to write beside it, because you're like, I need to think this out, and you want to write the decimal, that's fine. But keep the fraction as best you can. Reduce the fraction as we get ready for tougher situations. Okay? That's my advice on fractions and decimals for now. My advice will change as we go along. Well, let's not wait around till tonight to find out you don't quite get this. You try that one. One little note. When you're using a formula, you should write it on the first line and the last line for sure. You can skip the ones in between. Some teachers don't let you. They want you to write the formula, on every, like the MAB on every line. But the big picture is first line and last line, and probably this one has a little therefore in front of it. I didn't bust you on communication really too bad in your test. I'm starting to mention these things a little more now to go, this is how these things should look. Well, you try that second one, and I'll do it very slowly in just a minute. I'm going to wait another 30 seconds, then I'll start. So if you really don't know what you're doing, then you can follow me in just a second. I don't know. Let's find out later. Here, I'll get you the note. You can grab someone beside you and copy. And then when I finish teaching, then you can go find out what the deal is, okay? No problem. Oh, I get it. Okay, here I go. Sorry, I got a little distracted there. How did it go? Did you get negative 4 comma negative 5 halves? Yep. Did you resist the temptation to go negative 2.5? No, I did not resist. let's do both for now, okay? Get a nice fraction at the end, and you can have the decimal underneath, and I'll mark the fraction. Moving forward, we need the fraction. I'll tell you one reason why, if you're like, I don't need the fraction. One reason why is when we get to later courses, like grade 11 is the big one next year, it won't be like this. It'll be like, we'll be trying to do things like 1 over x minus 2 plus 1 over x. And you better know what you're doing with fractions at that point, because the fractions, it won't be so obvious what the heck is going on, okay? So I just put that up there to go, that's why we have to stay good at fractions. Is this the perfect example to talk about it? No. Okay, what's one form error that you'd like to improve on mine? There's nothing wrong with my answer, but a little bit better mathematical form. What should I have done? Last one should have a therefore and a statement of what you were trying to find in there as well. So yes, you can leave some blank lines where you don't have to have something on the left, but on the last line it's got to come back. Okay? Questions there? Okay, last example. If the midpoint of a line segment EF is negative 3, 4. You had to know this was coming. Every math lesson is like this. Let's find it left to right. Let's go. I'll give you the stuff over here. You find the stuff over there. And then it's like reverse. Oh, I'll give you the answer. You got to find where it came from. But I want to underline one word that should scare you a little bit. And one endpoint is 1, 2. Algebraically calculate the other endpoint. So there's a graph there, and the graph's there for me to show you afterwards what's happening, but it's asking you to do it algebraically. Algebraically means write down the formula and solve it using the formula. So let me write down the formula here. Midpoint of EF is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. This is like a mini preview of the type of questions that we're going to get into in this chapter. Locked? With a little more thinking. It's not just going to be plug into the formula. You got to think about what's going on here. Now they told me the midpoint is negative 3, 4, so this is a little bit scarier because they give me that part of it. They give me one of the points, but they don't give me the other point. Really scary if you haven't seen stuff like this before. You're like, well, how am I supposed to do it? Well, you sub and solve. That's what we call it in all the other grades. Sub and solve. So the first coordinate comes out to this, because I know it's a 3. Oh, negative 3, sorry. And the second coordinate comes out to this, 4 plus y2 over 2. And then I pause, because you might panic. You might get to there and go, oh, what am I supposed to do now? Anyone have any suggestions on what I could do now to deal with this?
You could do negative 3 equals to 1 plus x2 divided by 6. And make separate equations.
Yes, separate equations. So I'm going to use a highlighter, okay? I'm going to highlight what she's talking about and say, well, there's the x coordinates. Those have to be equal. That's what has to happen here. So when I go back to here, is I can then go, my first equation is negative, in highlighter. That'd be good. I'll just do it all in highlighter. There we go. The first equation says negative 3 equals negative 3 plus x2. Sorry, having a real trouble with my pen here today. Over 2. This is very upsetting, though, because you might be like, well, yeah, that's one equation, but the other equation is this. Which one do I solve? I'll go after the first one, and we'll see if it's enough to get me the answer. Okay? Whoa. Ooh. Opposite of dividing by 2. Multiply by 2. Okay, so that 2 comes over and multiplies. That's not so bad. And then the opposite of the subtract 3 I got there, or that negative 3, add 3, so I'll move that over. Hold on, friends. So distracted. I subbed it in wrong. Anyone see where I subbed it in wrong? Do you see it? I put the negative 3, 4 over here, and I also put it over here. I already saw it because I'm going to get negative 3 as the answer. Negative 3 can't be the answer. Sorry, I hope you did it in pencil. This is why we do it in pencil. Rewind, rewind, rewind. Yeah. Crap, someone says. All the way back to here. Goodness gracious. The x, 1, was not that, it was 1. And the y1 was not 4, it was 2. The rest is the same, though. Now, I erased everything. You probably didn't have to erase everything. You could have just fixed it. And then the other one. There. That's better. Oh, my goodness. That's an important lesson, though. Maybe I was getting bored because I thought this was easy. And it's easy to make little mistakes when you get bored. I saw somebody write in their test, remember to slow down. They were talking to themselves. I could have used that advice just a minute ago. Slow down. Make sure you get the numbers right. That was very clever of that person to write that on their test. Anyways, negative 3 times 2 equals 1 plus x2. And then bring the 1 over, and I get negative 7 equals x2. Ah, that's better. Much better. Does that answer the question? No, I'm not done. That's why there's 2 equations. Because that gives me the x value. Now I need the y value, so I do it all again. 4 times 2 equals 2 plus y2. That's 8. And I get 8 minus 2 equals y2. So the y2 is 6. Therefore, f equals negative 7, 6. Why f? Because they said that in the question, I think. The other endpoint is f. Now, let's do it graphically. Then we need someone clever to tell me why we shouldn't rely on graphically. Well, you start thinking about what types of numbers. These were nice numbers. So what did I get? The midpoint is negative 3, 4. Negative 3, 4. There it is. And then they gave me one endpoint. 1, 2. And then to get the other endpoint, I think I'd use your slope trick. As I just go, okay, over 4 up 2, over 4 up 2. There's the other endpoint, which is negative 7, 6. And you might, at that point, go, isn't graphically way better? And I do agree that if the numbers are nice, that graphically is way better. I 100% agree with that. So then my last question of the day is, what types of numbers, and there's two great answers available to this, what types of numbers would graphing not work too good? Decimals. You're going to be estimating. You're going to be like, eh. So that's why we have formulas instead of graph. Yes, I agree. If the numbers are nice, graphs are way better. But if the numbers are decimals, graphs is going to be a disaster. Yeah. Big numbers. Who wants? If I had said 7,402,000 negative 832, who wants to graph that nonsense? I mean, it is possible. You could say, oh, well, I can make the scale this or that, but no. The formula is going to be much easier. In fact, some of you might be so good at equation solving, you don't even need all the steps I did there. Just some of the steps after you do a couple of them. The divide by 2 is trouble here, but a reminder, the opposite of dividing by 2 is multiplying by 2, so that gets me out of trouble here. Just want to double check your first page. Does the homework match up? Page 78, 1 to 6, 9 and 11. 9 and 11 have little stars beside them. A little warm up for some of the tough stuff that's coming later. So zip through the first few and then get to 9 and 11 because they both have stars. Any questions for me? On the lesson.